Hey, this is Horner. We're going to look at the different types of osmotic solution. So the first one's called a hypotonic solution. Hypo here means under, so you could think about of a hippo being under the water. Isotonic means equal, so isotonic solutions. And then hypertonic solutions, hyper means above, so you can kind of think about your hyper friends, and that'll help you with some of these terms. What you're filling out when you do the notes is your interactive science notebook, and you're looking at the different types of osmotic solutions. So you'll be writing in these spaces as we go through the notes. So feel free to pause when you need to, otherwise we'll just keep moving. In a hypotonic solution, there's a higher concentration of something inside the cell than outside. So it's hypotonic because you have a smaller concentration of something outside than you do inside the cell. So to try to equal that out, water moves into the cell to try to equal out the concentration. If that happens, then the inside of the cell can get too full. For example, an animal cell will get too full and it will swell and it might even burst due to all that water moving in. So this is kind of a picture of what's going on. We've got too much salt inside of a cell and we have too little salt on the outside. So water rushes into the cell to try to make sure that this is diluted, the salt is diluted, and when it does that, some of the cells will swell so big that they'll actually rupture. In a plant cell, the cells will remain in a normal, we call that a turgid state, but the vacuoles are really huge. They are swelled and they are full. So this would be, if you go to the grocery and you try to buy celery, this would be celery that would be really stiff. It'd have plenty of water on the inside, wouldn't be wilted at all. Plants that have this condition tend to be standing up pretty tall, look pretty healthy, although they might have a lot of water within the cell itself. And that's a hypotonic solution. An isotonic solution, the inside of the cell and the outside of the cell have an equal proportion of concentration. So you'll notice that I have 1, 2, 3, 4, 5, 6, 7, 8 dots here, and 1, 2, 3, 4, 5, 6, 7. So it's pretty close. You might have another hidden dot on the inside of this cell. So we have an equal concentration, so water can just easily move in and out without any trouble. And in an animal cell, this is just the normal condition. And we say that because it's the normal condition, it's in equilibrium, we say that's homeostasis has been reached. In a plant cell, the vacuole is of a normal size. It's full, but it's not swollen really big and misshapen. So we say that the cell condition here is also normal. So really easy for isotonic. For the last one, this is hypertonic. The concentration inside the cell of particles is less than it is outside of the cell. So water moves out of the cell to try to even out the concentration. So it's trying to go to where all these particles are. It's not real happy on the inside. When that happens to an animal cell, like a red blood cell or a cell in a beaker, the cell's lost so much water that it becomes shriveled. And it becomes smaller. A plant cell, the vacuole, when it loses water, the cytoplasm kind of shrinks away from the inside of the cell wall, and the plant starts to wilt, and we call that a loss of turgidity. And those are the three different types of solutions. So hopefully you have paused this video enough that you can write everything down about each one, and that is it.